AC circuit with resistance and capacitance in series. This is resistance, this is capacitance. Voltage across resistance is VR, which is equal to IR. Here, current and voltage are in same phase, and the voltage across capacitance is VC, which is equal to SC times I. Here, current leads voltage by pi by 2. This is voltage source E equal to E0 sine omega t. This is phasor diagram. This is voltage across resistance. This is voltage across capacitance. And this is resulting voltage. This angle is phi. This is omega t. And this angle is 90 degree. So now let's write equations. VC in terms of vector, I'm writing VC equal to HC times I, and VR equal to R times I. So net voltage E will be VC plus VR. Here, algebraic sum of voltage across capacitance plus voltage across resistance will be greater than the applied voltage because they are mutually perpendicular. So E will be the resultant of the two. Like if this is, suppose this is VR, this is VC, then E will be equal to root of VR square plus VC square. Now let's apply Pythagoras theorem here. So as I told you, E equal to VR square plus VC square. Let's take peak values. So E0 square equal to V0 square across capacitance plus V0 square across resistance. This can be written as I0 square XC square, that is plus I0 square times R square, which is equal to E0 square times R square plus XC square. So we can find the value of E0 means peak current, that will be equal to, sorry, I0 is peak current, which is equal to E0 divided by R square plus XC square with under root. Here, R square plus XC square is called impedance, which is denoted as Z. So, Z equal to root of R square plus XC square. But remember, XC equal to 1 upon omega C. So this will become the root of R square plus 1 upon omega square C square, but omega equal to 2 pi F. So this will become root of R square plus this 2 pi in place of omega. We can write 2 pi F. So 1 upon 4 pi square F square times C square. And this can be evaluated. Here we try to find phase. So phase angle we draw impedance triangle. Suppose this is XC and this is R. This angle is phi. This is Z. So tan phi will be equal to XC upon R. Even cos phi can be found. So this one hypotenuse. And the current is written as I equal to I0 sine omega t plus phi. Here, phi is angle between resulting voltage and voltage across resistance. Now, let's understand the same concept with the help of some numericals. So, question number one. What is the value of current in AC circuit containing R equal to 10 ohm, C equal to 50 microfarad in series across 200 volt 50 hertz AC source? So, we are given R equal to 10 ohm, C equal to 50 microfarad means 10 power minus 6 farad applied voltage, that is VRMS is 200 volt, and frequency is given as 50 hertz. So we can find Z. Z equal to root of R square plus XC square, that is the root of R square plus 1 upon 4 pi square F square C square. We can put the values. So it will become root of 10 square plus 1 upon 4 pi square into F square, that is 50 square, times capacitance, that is 50 into 10 power minus 6 square. So if we simplify, it will come out to be 100 plus 4053, that is root of 4153. This is roughly equal to 64.44. Now IRMS will be equal to VRMS divided by Z. So VRMS we have 200 volt, and Z we have found at 64.4. So this will be equal to 3.1 ampere. Let's see next question. When an alternating voltage of 220 volt is applied across device X, a current of 0.5 ampere flows through the circuit and is in phase with applied voltage. When the same voltage is applied across another device Y, again the same current flows, but it leads the voltage by pi by 2. Name the device X and Y, compute the current in the circuit when the same voltage is applied across the series combination of X Y. Clearly, here current and voltage are in same phase, it means it is resistance. And in second case, since current leads voltage by pi by 2, it means it is a capacitance. So let's evaluate. X is a resistance and Y is capacitance. Now we can find resistance because voltage is 220 volt and current flows 0.5 ampere. So R equal to 220 divided by 0.5, which is 440 ohm. And it's when same voltage is applied across device Y, then same current flows. It means XC is also 450 ohm. Now we can find impedance Z. Z is equal to R square plus XC square, that is 440 square plus 440 square, that is 440 root 2, which will give 622.25 ampere. Now we have to find out IRMS. So IRMS equal to VRMS divided by Z. So VRMS is given to 20 volt, 20 divided by 622.25, and and this will be equal to 0.35. Let's see next question. An alternating current of 1.5 milliampere and angular frequency omega equal to 100 radian per second flows through a 10 kilo ohm resistor and a 0.5 microfarad capacitor in series. Find the RMS voltage across the capacitor and impedance of the circuit. So let's see the solution. Here omega is given as 100 radian per second. And IRMS is given 1.5 milli instant power minus 3 ampere. R is 10 kilo ohm, means 10 into 10 power 3 ohm. Capacitance C equal to 0.5 micro 10 power minus 6 farad. Now we can find impedance Z. Z equal to root of R square plus 1 upon omega square C square. Put the values. So it will be equal to Z equal to root of R is 10 into 10 to the power 3 whole square plus 1 upon omega square means 100 square multiplied by capacitance 0.5 into 10 power minus 6 square. So it will become root of 10 power 8 plus 4 into 10 to the power 8. We simplify this. So this will be equal to 10 power 4 times root 5, which will be equal to 2.23 into 10 to the power 4 ohm. Now we have to find out voltage across capacitance. VC RMS will be equal to XC times IRMS. So XC is this much with square root. So 1 upon omega C times IRMS. So we can put the value of 1 upon omega C. Omega is 100 and capacitance is 0.5 into 10 power minus 6 into IRMS is 1.5 milliampere 10 power minus 3. So it will come out to be 20 volt. Let's see next question. A resistor of 200 ohm and a capacitor of 15 microfarad are connected in series to a 220 volt 50 hertz AC source. Calculate the current and the RMS voltage across the resistor and the capacitor. Explain why the algebraic sum of these voltages more than the source voltage. So as I told you, if voltage across resistor is VR, then voltage across capacitance is VC. They are at 90 degree, and source voltage will be the resultant of the two. So we can say VC square plus VR square will be equal to E square. So clearly, let's take some example. Suppose VC is 80 volt, so 80 square, and suppose this is VR is 60 square. So this will become 100 square. So if we find algebraic sum 80 plus 60, that will be 150, but the resulting voltage will be just 100. So this is the concept here. Explain why the algebraic sum of these voltage is more than the source voltage. Now let's start the question. So we are given C equal to 15 microfarad, that is 15 into 10 power minus 6 farad, and VRMS is given as 220 volt. Frequency is given as 50 hertz. So let's find out capacitive reactance. X equal to 1 upon 2 pi FC. That is 1 upon 2 pi into frequency. times 115 into 10 power minus 6. So this will come out to be 212.30. Now we try to find out impedance Z equal to root of XC square plus R square. So the root of XC is then 212.3 square plus resistance. So here resistance is given as 200 ohm, 200 square. So this will come out to be 2.91.5 ohm. Now we have to find out IRMS. So IRMS will be VRMS divided by Z. We put the value of VRMS as 220 divided by Z equal to 291.5. So this will give 0.755. Now VRMS across resistance and across capacitance we can find. So VRMS across resistance, VRMS across resistance. So that will be equal to IRMS multiplied by resistance. So IRMS we have got as 0.755 into resistance is given as 200 ohm. So this will be equal to 151 volt. And then VRMS across capacitance. So IRMS times XC. So times XC. So IRMS is 0.755 into XC. XC we have found as 212.3. Multiply, we will get 160.3 volt. Clearly, the sum of VRMS, these two voltages, like if you find VRMS across R plus VRMS plus C. So it will be more than 220 volt. It will be 151 plus 160.3. But if we find this value resultant by using Pythagoras theorem, so what do we get? So suppose we want to evaluate effective voltage. So that will be equal to root of 151 square plus 160.3 square. So it will be 220 volt, which is correct. Thank you for watching.